Hello everyone, myself Mikal Tamang, student of Sikkim Namchi Government College, BSc in Physics, 4th semester. Today I am here to give a short presentation on my topic Landé G factor. Index. In this topic, we will see a brief description on its introduction part, G factor, Landé G factor and its derivation, significance and conclusion. Introduction. In physics, the Landé G factor is a particular example of a G factor, namely for an electron with both spin and orbital angular momenta. It is named after Alfred Landé, who first described it in 1921. In atomic physics, the Landé G factor is a multiplicative term appearing in the expression for the energy levels of an atom in a weak magnetic field. Now we will see about the German physicist or German-American physicist. He was Alfred Landé, who gave the Landé G factor, and he was born on 13th December 1888 and he died on 30th October 1976. He was a German-American physicist who was known for his contribution for quantum theory. So now we will see a brief description about what G factor actually is. A G factor, also called a G value or dimensionless magnetic moment, it is a dimensionless quantity that characterizes the magnetic moment and angular momentum of an atom, a particle or the nucleus. In quantum mechanics, the G factor is a part of the calculation for the gyromagnetic ratio, where gyromagnetic ratio means the ratio between the magnetic moment of a particle to the angular momentum of the same particle. So now, as we have learned about what G factor actually means, so now we will see a brief description about what actually Landé G factor means. Landé G factor, it is a multiplicative term appearing in the expression for the energy levels of an atom in a weak magnetic field, and it is denoted by Gj, where Gj is equal to, as you can see over here, Gj is equal to 1 plus j bracket j plus 1 minus L bracket L plus 1 plus S plus 1 whole divided by 2j j plus 1, where j is the total angular momentum and S is the spin angular momentum and L is the orbital angular momentum. So now the derivation part. Here, as you can see, in the weak field limit, we assume that the magnetic dipole moment due to the electron in the atom is proportional to the total angular momentum, and here we have derived the Landé G factor, where J denotes the total angular momentum of an electron in an atom and L is the orbital angular momentum and S is the spin angular momentum, where J equals to L plus S, where the total angular momentum J of an electron in an atom is the vector sum of the orbital angular momentum L and the spin angular momentum S, and where the mu L, mu J and mu S are the magnetic dipole moments associated with orbital angular momentum L, spin angular momentum S and the total angular momentum J respectively. Now, as we have derived the expression for Landé G factor, Now we will see the significance of the Landé G factor. Now we will learn what is the significance of Landé G factor. The significance of Landé G factor, as you can see, that the G factor is important because the behavior of the electron spin can be manipulated by controlling the electron G factor. It is a quantity which characterizes energy levels of electron in magnetic field. So now here is the conclusion of this Landé G factor presentation. A Landé G factor, it is a dimensionless quantity that characterizes the magnetic moment and angular momentum of an atom, a particle, or the nucleus. For a purely orbital moments s equals to 0, where j equals to L, the Landé splitting factor is equal to 1, and for a purely spin moment L equals to 0 and j equals to L, it is equal to 2, where j is the total angular momentum, L is the orbital angular momentum, and s is the spin angular momentum.